So, the notes that we're taking are on complex fractions.
Would you like me to give you my paper that I was supposed to provide?
Yeah, you can come up and put it in the box. Right up here. Right up here. All right. So on the quiz, I actually gave you a complex fraction problem because complex fractions are kind of a combination of the last two things we've done. So we looked at multiplying and dividing problems, and then we looked at adding and subtracting problems. You can put it right up here. And then complex fractions just combine those two ideas. So for you guys, I put it on the quiz as a bonus because it is within your ability to do it without me teaching it to you. Although I will. I'm going to show you guys how we can do that by putting all those steps together. But you're definitely capable of doing it without being taught because you have all the pieces to already do it. So the bonus question on the test said to simplify. And the problem on the, or not on the test, but on the quiz, the problem on the quiz said x over 4 plus x plus 1 over x, and that whole thing was being divided by 3 over 4x. That was the quiz problem. It was a bonus. So if you look at this, I can see that this is an addition problem because I have two fractions being added together on the top. But it's also a division problem because I've got something on the top divided by something on the bottom. So it's a combination of two ideas that we've already learned about separately. So first, we're going to focus on the addition part. So what do you guys do when you have a plus in between two fractions? What do you need to do?
You find the
Common denominator. So what is the common denominator between those two fractions? 4x. Okay? And now what should you do?
No, you gotta make it so that the fraction has both.
Yeah, we need to make sure that each of these fractions on the top have the common denominator. So how do we do that? Take the first one and multiply it by x on the top and x on the bottom, right? And this one has an x, so what does it need on the top? It needs a 4. Okay, so at this point on the top of our fraction, we've got x squared over 4x plus, what else do we have? 4x plus 4 over 4x. And I'm just going to keep writing the bottom even though I didn't do anything with it. All right. Once our fractions have those common denominators, what is our next step? Say again? Yeah, combine it. You write it as one fraction. So on the top, I'm going to have one fraction with 4x as a denominator. So how do I write the top part out? X squared plus 4x plus 4. And then on the bottom, I've got 3 over 4x. Okay, so we are done with the part where we have added fractions together. We've done that whole process. We're completely finished with that. Now we have to consider that we've got one fraction divided by another fraction. One fraction divided by another fraction. What did we always do when that happened? Keep, change, flip, right? So I'm going to keep the one on the top. I'm going to change it to multiply. And I'm going to flip the one on the bottom. And then what do you guys notice when I did that?
Cancel.
Yeah, we got stuff that can cancel. 4x. Yep, and you can do a diamond. So if we look at this, I can see that the 4x's cancel, right? And then I can also see that there's some factoring that I need to do. So x squared plus 4x plus 4, how do we factor that? That's a diamond, right? So we are multiplying to 4, and we're adding to 4, and that's 2 and 2. So what we really have on the top is we have x plus 2 and x plus 2. And then on the bottom, all we have left over is a 3. And that is actually all. That's our final answer. Some students on the quiz said that they could see that you could factor the top, but the x squared plus 4x plus 4, they left it. And they did that because the top and the bottoms don't cancel at all. So either one of those answers is totally fine. So a lot of people got this right as a quiz bonus question, even though we've never learned it before, and I thought that was pretty cool. You guys got it. So what we want to do, there's actually an easier way to do these problems, so we want to go back and we want to do these problems in a slightly easier way. So when we canceled out the 4x and the 4x, what was that from the original problem? If you go back up here, up to the top, what was that in the original problem? That was the common denominator, right? Okay. So it was this 4x right here canceling with this 4x down here. You guys see that? So what we can do when we approach these complex fractions early on in the problem, if we can get a common denominator between these two pieces on the top but also this piece on the bottom, then we know that if we were to do the whole problem by hand, when I flip this one up, these two denominators would be in the same, they'd be one on top, one on bottom, they would cancel. Does that make sense? So this is the denominator from the top of the fraction. This is the denominator from the bottom of the fraction, but we flipped it. We all got that? Yeah. So what we're going to do is we're actually going to go back to the original problem, and I'm going to say I've got a common denominator here, and here, and here. And once I do that, I can get rid of my denominators like this. And when I do that, I get, that's my x squared, plus, this was 4x plus 4 over 3, and I'm done. And I did not have to do any of that. You guys see? Did you see how tricky we were? Not. Okay, so we're going to do another problem, but we're going to try the trick this time. Save ourselves some paper. Okay, are you ready? All right, example number 2. So this one, we have 11 over x plus 3 over 2 divided by 5 over 2. So this process only works if you find a common denominator between all of your denominators. So what is the common denominator between all of our denominators? 2x.
You can add an x to the bottom.
Mm-hmm. So the first one has an x. What does it need? 2. So 2 on the top, 2 on the bottom. This one has a 2. What does it need? It needs an x. X on the top, x on the bottom. This one has a 2. What does it need? It needs an x. X on the top, x on the bottom. Okay. Now that we have common denominators, we know that if we kept doing the problem and we ended up doing keep it, change it, flip it, that the 2x's and the 2x's would cancel. And so what we can do right now is we can just get rid of these denominators.
So now we got
22
plus 3x over 5x.
Mm-hmm.
That's the answer.
Yeah, at this point we would say I just need to simplify this. In this unit, what does simplify mean? Factor and cancel. Can you factor the top or the bottom? Does the top factor? No. The only type of factoring it could possibly be is GCF, and there's no GCF there. So that means that's it. We're done. Okay, we're going to try another one. We got 5x over 3 plus x over x plus 1 divided by 2. 5x over 3 plus x over x plus 1 divided by 2. Now this problem's a little different compared to the other ones. Do you guys notice what's different about this one?
It has an x plus 1.
It does have that. Yep, the denominator is a little different.
The bottom only has one number.
Yeah, this is not written as a fraction. So how can I take 2 and write it as a fraction? 2 over 1. Yep. Okay. So, and as we do this example, we'll go ahead and write out steps for these. So the first thing is to make sure everything is a fraction. So this whole number 2 had to be written over a 1. So make sure all terms are fractions. So this one has 3 terms. We got one right here, there's one right here, and there's one right here. And we wanted to make sure each of them are fractions. Now what do we do? Yeah, common denominators. Get common denominators. So what is the common denominator for this problem?
6. I mean, yeah, 6.
Hold on. 3 together.
Wait, we got a 3, we got an x plus 1, and we got a 1.
The x plus 1 is plus.
Okay, so we need an x plus 1. And what else do we need? We need a 3.
3 times 2?
Wait, the 2 is not a denominator, right? So if we look at the denominators, we got a 3, an x plus 1, and a 1. Do we need the 1 in the common denominator? No, because it's not going to do anything. Okay, so this one has the 3. What does it need? X plus 1. This one has the x plus 1. What does it need? 3. And the other one needs everything. So it needs a 3 and an x plus 1. Needs a 3 and an x plus 1. Okay. Once we have the common denominators, what do we do to all of our denominators? Yeah, we cancel them all out. We get rid of all of them. So I'm going to say the third step is to ditch the denominators. So what do we do? Do we say 5x plus 3x is 8x? No. Why not? We have this x plus 1 right here, right? What do I do with the 5x and the x plus 1?
Use
Distribute. You got to multiply those. So 5x multiplied by x
5x squared plus 4,
plus 5x. So you got to make sure you distribute it. And then plus the 3x over there.
over 2.
Divided by, how do I multiply this out?
you
Well, which do you distribute, the 2 or the 3?
the 2 multiply the 2 and 3.
Okay, so if you multiply them together, what number is that?
6.
6. And then what are we doing with the 6? Distribute it. So we're going to say 6 multiplied by x is 6x. 6 multiplied by 1 is 6. Okay. And then what should our last step be? Simplify, right? Okay, do you have any like terms on the top you can combine?
X.
Yeah, 5x and 3x, what does that give you? 8x. So I'm going to go ahead and flip my paper over. I've got 5x squared plus 8x. And then on the bottom, did I have anything I could simplify on the bottom? 6x plus 6 in your like terms?
6.
Yeah, so at this point in the simplifying process, this is where we factor, right? Once all the like terms are combined. So how do you factor the top? GCF of x. So take out the x, and what's left over? 5x plus 8, okay. And then on the bottom, how do we factor that? 6. And what's left over? X plus 1. And does anything cancel? No. So that means that this was a good final answer, and that this right here is a good final answer. Yeah. Just going to give people a little bit right. All right, now some of you guys might have noticed that this denominator was kind of like already in factored form a little bit. It was 2 times 3, and then it had the x plus 1. So sometimes complex fractions have 2 fractions on the top and 1 on the bottom. Sometimes they have 2 on the top and 2 on the bottom. Sometimes they have 1 on the top and 2 on the bottom. There's a lot of different combinations. So if you can see ahead in the problem and you can say, that's already factored, I'm just going to leave it factored in case it cancels, you're welcome to do that. Okay, some of you guys might have seen ahead in that problem, but with these ones, there's not like a rule for it like there is with adding and subtracting because it's different every time. Okay. Any questions on the complex fractions?
Did you get that?
Yeah.